Hello everyone, welcome to Maths IEC. Today we are going to discuss about the theory part related to Kirchhoff's laws. Now there are two Kirchhoff's laws you need to know, so let's discuss about each one. The first Kirchhoff's law is a really simple and a straightforward one. All it says is the total current entering a point is equal to the total current leaving that point. Uh, so what that really means is that if you think about a junction in an electric circuit, the amount of charge that flows into that point is exactly equal to the amount of charge that goes out of that point. Obviously, that should be the case because charge is conserved. Charge cannot miraculously appear or disappear in that junction. So, the total amount of current that flows into the point is equal to the total amount of current that goes out from that point. So that's why we say that this is a consequence of conservation of charge. Now let's look at a simple example. So if you think about current capital I flowing into this junction, and you have two branches where current lowercase I1 and I2 are flowing out. So the total current flowing into the point capital I is equal to the total amount of current going out from that point, which is I1 and I2. Now, uh, you can sometimes bring these I1s and I2s to the left hand side. So you can come up with this formula, this version really. I minus lowercase I1 minus lowercase I2 is equal to 0. Or, in other words, you can say the sum of currents entering and leaving a point is equal to 0. Now here, if you take current going into the point as positive, current leaving out should be taken as negative. So that's another way of saying it. But simply, the first version explains the basic idea behind Kirchhoff's first law. So you can summarize this as sigma I is equal to 0. Now let's consider a slightly complex situation. Here you have another diagram where it's not as straightforward as the first one, but for the convenience, I just marked the currents flowing into the point. I just colored them with yellow, and the currents flowing out of that I marked with green. So you can mark, you can write capital I1 plus capital I2. Those are the currents that are going in, is equal to lowercase I1 plus lowercase I2 plus lowercase I3. So again, if I can move it to the other side and I can write the other version, I1 plus I2 uppercase, take away lowercase I1, take away lowercase I2, take away lowercase I3 is equal to 0. So this is the idea behind Kirchhoff's first law. Now, we need to use both Kirchhoff's first and second law in conjunction when it comes to a question. And I will show the second law as well. And then I'll show how to use this in a series of examples and how to do some of the calculations. Right, now let's look at Kirchhoff's second law. Now, the second law says that the sum of EMFs around a closed loop is equal to the sum of PDs. So if you look at a very simple circuit like the one you can hear, so you got two power supplies, EMF1 and EMF2. There are three resistors in this example, PD1, potential difference 2, potential difference 3. I can call them V1, V2, V3, something like that. Now, all this law says is, if you consider this closed loop, the amount of energy supplied by the energy givers. So you can see the EMF1 and EMF2, the power supplies, they give energy to the system. These are energy givers. These are energy consumers. So, according to the law of conservation of energy, the total amount of energy supplied to the circuit by the energy givers should be equal to the total amount of energy consumed by the energy consumers. So that's why we can say that this is a consequence of conservation of energy. So we can simply write the Kirchhoff's second law in this, as long as this one, you can say the sum of EMF, sigma EMF, is equal to the sigma PD. So I can write it exactly for this one. So I can write EMF 1 plus EMF 2 is equal to the sum of PDs, in this example, PD1 plus PD2 plus PD3. So this is the second law. So Kirchhoff's first law says that the sum of currents entering a point is equal to the sum of currents leaving that point, conservation of charge. The second law says around a closed loop, around a closed circuit, the sum of EMFs is equal to the sum of PDs, and this is a consequence of conservation of energy. In the next video, I'm going to take a simple example and I'm going to talk through step by step how to do a typical Kirchhoff's law question. In fact, I think I've made about 3 or 4 different examples because it'll take a couple of examples to get the hang of it. So I'm going to show how to do a calculation using Kirchhoff's laws.